Hey everyone, this is lab 12 in your lab manual, but technically it's the 11th lab we're doing. So I'm calling this lab 11/12. But anyway, it's the last lab of the semester. In this lab, we're looking at heats of reactions, so enthalpy changes of chemical reactions. So I posted on YouTube a video that Scott made. Once again, you're going to have to watch this video that Scott made. You're going to have to make observations and record all of your data. Based on this data, you can do calculations, answer the questions, hand in the lab report the way you've been doing it since spring break. So yeah, let's just get into it. So this is going to be a 3-part lab. So the data you're collecting for this lab, you should be collecting data for all 3 parts. In part 1, we're trying to find the heat capacity of our calorimeter. So part 1, we got to find the heat capacity of our calorimeter. Once we find the heat capacity of our calorimeter in part 1, we're going to study 2 chemical reactions. So number 2, the chemical reaction we're studying is called a solution process. And specifically, we are taking potassium chloride solid, we are adding it to water, and the potassium chloride dissolves. So you got these ions floating around in solution. This is called a solution process. And the heat of this reaction, the change in enthalpy, the delta H of this reaction, is called the heat of solution. All right, so we're going to measure the heat of this chemical reaction. It's called the heat of solution for potassium chloride because it's a solution process. Part 3 of this experiment, we are trying to study the heat of another chemical reaction, and we're going to find the heat of this acid-base reaction. So you take some hydrochloric acid, you react it with sodium hydroxide. It is a neutralization reaction because you make water and a salt, in this case, NaCl. So we're going to study the heat of this reaction as well. And the heat of this type of acid-base reaction is often called the heat of neutralization. Why neutralization? Because we're starting with an acid and a base, and we make neutral products. All right, so heat capacity of our calorimeter, part 1. Once we know that, we can measure the heat of solution of potassium chloride and measure the heat of neutralization for this acid-base reaction. Okay. Again, you're going to have to watch the videos and collect the data. I think the tricky part in this experiment is what do you do with all of these numbers? Well, luckily for us, for all of these parts, at least part 1 and 2, you can use your lab manual. So for part 1, if you want to know, hey, how do we use these data to come up with the heat capacity of our calorimeter? In example number 1, I walk you through this. All right. If you want to know, hey, in part 2, how do I find the heat of this chemical reaction? Which is called the heat of solution. Well, luckily, let's see, again, I'm terrible at this. I walk you through that in example number 2. So, for help with your calculations, for part 1 and part 2, I would certainly work through these examples and make sure you understand what's going on. For part 3, let's make sure there's not an example. There's not, but man, if you can do part 2, you should be able to do part 3. All right, the big idea with all of these calculations is we're relating a heat. So notice I'm using heat and enthalpy synonymously. At constant pressure, a delta H is the same as a heat. So delta H and Q are going to be synonymous, the same thing. Delta H and Q are the same thing. And what we're really doing with calorimetry in this lab, calorimetry, we are relating a heat to a change in temperature. How do you relate a heat to a change in temperature? Well, it's related through the specific heat of something, or more generally, a heat capacity. Okay, so in this lab, we're trying to relate a heat to a change in temperature. In this equation, M is the mass, CS is the specific heat, and delta T is the change in temperature. So for example, what if we had 5 grams of water? Water has a specific heat of 4.184 joules per gram per degree C. And what if we measure a change in temperature of 2 degrees Celsius? So we have 5 grams of water. We put some heat into it, and the temperature goes up by 2 degrees Celsius. We can use this equation and the specific heat to relate a heat in energy to a change in temperature. So let's do that. How could we find the heat that was added to this water? Well, we need the mass of the water. We need the specific heat of the water. And we need the change in temperature of the water. You always need to keep track of your units. Okay, in this lab, we're going to use both specific heats, which are joules per gram per degree Celsius, but we're also going to run into a heat capacity, specifically when we talk about our calorimeter. The heat capacity of our calorimeter is just simply joules per degree Celsius. We don't have a per gram. So a specific heat is per gram, a heat capacity is not. Why would it be useful to have a specific heat for water? Well, we can look this number up and we can apply it to some amount of water of any mass we want. That's convenient, right? Because presumably we're going to have experiments where we have different amounts of water. Okay, so being able to multiply a specific heat by the mass allows us to change the mass of water. Do the units work out? Our degrees Celsius cancel, our grams cancel. We're left with joules. This would be 41.84 joules. So in other words, if you take 41.84 joules of heat and put it into 5 grams of water, the temperature should go up by 2 degrees Celsius. Okay, so in all of your calculations, we're relating a heat to a change in temperature. All right, in this lab, kind of a confusing part for a lot of students is the sign of the heat. Is it positive? Is it negative? I would say do not worry about the sign at all until we're trying to find the heat of our 2 reactions. So in your lab report, if we look at part 2, come on, camera, there we go. If we look at part 2, the only time I would worry about the sign is when we're trying to find the heat of the reaction. So question 8 here, calculate the heat of solution of KCl. So in other words, we're using our data to find the heat of this reaction, the solution process. When we have to calculate the heat of the reaction, then you need to worry about the sign. For part 3, the heat of neutralization, again, don't worry about the sign. Don't worry if it's positive or negative until we have to find the heat of the reaction, which is on the next page. Here we go. Question 13, calculate the heat of the reaction. Okay, so for question 8 on part 2 and question 13 on part 3, those are the only times you need to think about the sign. And it's pretty straightforward. If a reaction releases heat, it has a negative sign. If a reaction absorbs heat, it has a positive sign. For all of the other parts of this experiment, don't worry about the sign. Just keep everything positive. Okay. So, and the reason this gets confusing is because we're trying to study a reaction that we will call the system. And the way we're learning something about a chemical reaction, the system, is by observing the surroundings. But we know from the first law of thermodynamics, if we have a reaction that, let's say, releases heat, All of that heat lost by a reaction must be gained by the surroundings. Okay, so in this lab, we're really looking at some chemical reaction. We'll look at two reactions, right? Heat of solution and heat of neutralization. And the way we do that is by observing the surroundings. So when you watch the video, you have, let's talk about part 2, KCl. So you have some styrofoam cups with a thermometer, and you have a solution in there. Or sorry, you have some water in there. You dissolve KCl and you make a solution. And you look at the change in temperature of that solution. So we're not studying the actual reaction, we're studying the surroundings. Okay, well, what are the surroundings? In that case, the surroundings are the solution itself, right? Because the solution can absorb heat or release heat. But also the calorimeter itself is going to get involved in the heat transfer. So for all of, and again, the examples walk you through these calculations, but the way we learn something about a reaction is by studying the surroundings. Part 1, we have to find the heat capacity of the calorimeter so we can include it in our calculations. Part 2, we're looking at heat of solution. We need to look at the heat gained or lost by the solution itself, but also the heat gained or lost by the calorimeter. Part 3, we're studying a neutralization reaction by watching the heat absorbed or released by the solution and the calorimeter itself. Just keep track of units, right? Make sure all of these things are in units of heat or joules. Again, I'm not going to go through specific calculations because I think the examples do a good job of that. But if you have questions, please let me know and I can help you out as best I can.